G'day guys, today I'm going to teach you how to build this little DIY Bluetooth gamepad. It's all 3D printed with a bunch of buttons and an ESP32 inside. These are little PCB backed buttons, just some 10mm push buttons. Now these switches, they're actually self-centering toggles, so it's like two buttons, one button one way, one button the other. I've got them at a bit of an angle. Got the thumbstick there with a clicky button underneath it. Two buttons on the side. Got a throttle on the left there. You can see the ESP32 if you have a squiz down there. So that's a total of 19 buttons and 3 axes with the thumbstick and the throttle. So what I'll do is I will give all the files down the down the bottom of the video here. You can go ahead and download those, print them out and follow along. So here's all the 3D printed parts, 2 legs, the cylinder, the buttons and the bottom. Here's the top. And we're going to start just by putting in all the electronics. So these switches, they just screw in. And what you want to do is get them in pretty tight. And for that last little bit, just get them on the angle you like. See, I'm angling mine out a little bit just for that, good thumb movement. So that one on the right is for my right thumb, and this one will be for my left thumb. So you want to angle it accordingly. Just have a test. Yep, that's good. Now, I didn't need nuts on those ones because there's quite a lot of plastic to bite into. This part there's not really, so you might get away with not having the nut, but I'm gonna put it on. And these ones I'm also gonna keep straight just because they're central. I might angle them a bit later, just if I find I'm using one with my right hand more, I might angle it to the right hand to make it a bit easier for me. That's up to you guys. Tighten those guys up. Now any 10mm diameter button should fit in here, but these are the ones I'm using. You don't want them to be too long in the cylinder because they might hit the ESP32 underneath. I like these big round ones. And just slide those in and put a nut on them. And that's pretty much all there is to it. Same thing with these guys, 2 more. Now the great thing when you're doing DIY is you can pick all your own colors for this. I've gone with the nice white plastic there, mostly because that's what I had in the printer. And the red and green buttons, because that's what I had in the box. But I think it turned out alright. And next is my thumbstick. Now you see I've got these little slots down the bottom. Now make sure you just align this so the pins at the bottom for attaching like the button and the things go through, and then these little metal things, they just fold over nice and tight to grip the whole thing on. So get them on tight as you can. Make sure there's not going to be any wiggle there. Yep, perfect. Alright, so he's done. Now make sure it's aligned correctly. It doesn't really matter which way it is around as long as it's sort of aligned north, south, east and west. And it'd be a bit of a tight press fit. You may have to sand the edges a bit. I didn't, but I've got my printer sort of exactly where I want it. So that shouldn't jiggle around. If it does, I would do a little bit of a trick I'm going to show you in a minute if it's jiggling. So this one is for my little PCB buttons. So these guys just drop in there. They should fit quite loosely. And what I've got here is a little PCB with 4 little push buttons and a hole in the middle. And this one's even a bit small. The spacing doesn't have to be perfect. I would have shown you how I made this, but this is actually something I'm ripping off another prototype I had. So just get it nice and tight in the middle. Make sure the buttons are still pressable. If you can't press them, you may have to loosen this a little bit. I'm tightening mine there. Just make sure it's aligned. And I've also just got another little screw hole there. I'm just going to put another screw there, and that's just going to hold down the edge to make sure it never spins around. And that's it. Make sure they're all nice and clicky. Slot them in there. Now the file you download will be a bit better than mine, but this one I printed, I didn't make this deep enough, so it doesn't actually slot in nicely. So what I'm going to do now is I'm going to get the soldering iron and just weld the edges a little bit to stop it falling out. I usually do this at about 320 degrees. So just get it in position and don't do the whole thing. just in case you ever want to take this out again, just a few spots, and that'll keep it pretty tight and prevent it going anywhere. Alright, happy with that. Just test those buttons, make sure I haven't forgotten anything, make sure it fits nicely with my bottom. And I have forgotten something. I forgot that shoulder button there. The same as the rest, slide him through, put the nut on, and let's do the base. So he's got a second right shoulder there, same way. And then we've got that throttle on the left, which is just this regular little 15mm pot. I'm putting a little washer on there, just so if it fits under there nicely. That's the washer that came with it. And a nut, get it on nice and tight. And make sure it's pushed all the way to the back, because this has to be like right in the center of that circle. Right, and this guy, the throttle, which I should have done in a different color, he just presses down on top. Make sure that's sort of all the way down to the base there. Alright, beauty. Make sure it all fits nicely. Get a feel for it, make sure you're happy with all your buttons, make sure the throttle still moves. And with the ESP32, he just drops in the middle there like that. And just make sure that whatever USB plug you're using is going to fit properly. If you've got some weird bulky one, you might want to open up that hole a bit. But this one, it's just a big square. It should be pretty lenient on you. And to hold it there, all I'm going to do is put a little bit of hot glue on either side. And the reason for that is I didn't want to put a complicated locking mechanism. I also thought I might put in a different microchip a bit later on. And also I'm just a little bit lazy. So we're going to put a bit of hot glue. So just make sure it's centered. Put a little bit on one side. Don't put too much because you might want to take this out again later. I'm going to get that out of the way. And knocked it out of place. And a bit more on the other side. Alright, once that's cooled down, we're ready to move on to the wiring. Alright, I'm going to start with the top because that's where all the hard work is. Alright, I'm going to put this in fast forward now because this obviously takes quite a while. So the first thing I'm going to do is do all my ground wiring. So for these switches, the ground's in the middle and either side is one switch direction. If you get lost at any point, make sure to go back and have a look at that schematic. For these switches, they're pretty simple, just one side goes to ground and the other side goes to an input pin. So I'm just going to pre-solder all my ground pins. And I'm going to be quite messy here. There's a bunch of ways you can do this. You could have every single ground wire going directly back to the microcontroller. What I'm going to do is bridge them all. So you can see I'm sort of building bridges from ground to ground. It's usually better to have short distances from the switches back to the ground. You don't really want to have them all in one long line because they can pick up more noise along the way. But it's sort of, you want to get a balance between, having the perfect electrical setup and also not spending all year doing it. And you end up with too many wires doing it that way, I think. So these little potentiometers on there, the way they work is they've got 3 pins and either side has to be ground and voltage, and then the middle gives the signal. It doesn't really matter which side is ground and which side is your 5 volts or 3 volts. All that happens is that you get the signal goes in a different direction if you have it the other way around. And this one here is the little press button. And I'm just testing to find out which 2 are my actual correct pins there. And now for each of these buttons, it's the same as the other press buttons. One side of the switch has to be to ground, and the other one goes to an input pin. So I'm just pre-soldering all my ground pins. And just working out a bit of ground wire. Now I'm going to do a little bit of color coding for my signals here. The main thing is I want to make sure I know which ones are my buttons and which ones are my analog wires. Because I want to make sure that the analog wires go to my ESP32 to pins that actually do analog to digital conversion. Now once I've done all those, I'm going to sort of wire them and bunch them together. The one thing I'll say about these 10mm switches is you want to be a bit careful with them. If you heat them up too much, the plastic that holds everything together can get a bit soft, and if the pins move around too much, then your button's not going to work anymore. So make sure you don't heat them up for too long, and make sure you don't put too much force on them and wiggle those pins around while the plastic is still warm. Alright, now I'm running a ground wire to the PCB. And it's got to jump around a little bit to make sure I get all 4 buttons. And I'm going to wire a bridge up to my little shoulder button there. And now the signals. So these are buttons, so I'll do these in purple as well. Alright, I'm just twisting them together just gently, and that's just because if they're all together, then if one gets a little tug, it's less likely to break off. They all share their strength. Apes are strong together. There's my 5-volt line. I'm just going to bridge those two together. And you see I just twisted one little wire together just so I can get the 5-volt split there. And I should put a little bit of heat shrink around that or something, but this is just a prototype. And yeah, I'm lazy. And there's that last little push button on the thumbstick. And the signal for the analogs, I'm going to make them orange. Like I said, they're the ones that you really have to keep an eye on. Alright, now what I'm going to do is I'm going to put a little Arduino Pro Micro in the base there. And the reason is my ESP32 doesn't actually do enough inputs. And the RR configurator software I've got actually lets you network 2 devices like this. So the ESP32 will be the master and will handle Bluetooth. And then this little guy down here will just be like a little, basically extra GPIOs. So I'm just going to pre-solder all of those. Now I put it there just so if I ever do need to upload some more code to this one, I can just take the leg off and plug the USB into it. And I've just got it floating on a bit of hot glue. Alright, so there's a ground wire for that. And the ESP32 and the Pro Micro need their grounds connected as well. All the grounds have to go together. The voltages don't go together. So my little pot here is going to get 3.3 volts from the ESP32. Now the reason we make sure the ESP32 does our analog is because it's actually got a better ADC. While the while the Pro Micro does, I think it's 8-bit, it can go from 0 to 1023. There might be 10-bit, I've got the numbers wrong in my head. The ESP32 can do something off the top of my head, I couldn't tell you. It's much higher than that, so you'll have much more accuracy if you do you'll have much better accuracy if you do your pots through the ESP32. Alright, so just going to twist all those 3.3 volts together and make sure they go to the 3v3 pin on the ESP32, not the VCC. The VCC will be 5 volts because that's connected straight to the USB. Now, I'm going to find out this was a mistake later, but those orange wires I've wired up incorrectly because they're actually not going to pins that can do analog to digital conversion. So don't copy those ones. The schematic you saw at the start, that is correct. That's not, it doesn't include this mistake I just made. So now I'm connecting my ground wire, and I'm just connecting it where I can easily connect it. What I'll do is all the buttons, I'll try and offload them onto the Pro Micro. Number one, they're sort of on top of each other, so there's not too far to go. And number one, it leaves me more room for playing around with the ESP32. So with the Pro Micro, you can go to sort of any pin between 3 and 16. including A0 through A3. Just don't do pins 2 and 3, because those are our communication pins. That's the I2C pins. You can see we're completely filling up this poor little Pro Micro. And now we need to put some pins, use up some pins on the ESP32. Oh, come on, you can do it, Jake. There you go. Okay, so this is just a prototype. I'm not actually going to put a rechargeable battery setup in this one, but not much point having a Bluetooth controller if it doesn't. So you can do yours just like mine, but you'll still have to run a USB cable to it for power, or else you can do this little setup which I've got here, which should be able to fit inside. I've got a 3.7 volt LiPo battery. That's one of those 18650s on the left there. They're pretty easy to get hold of. I got these ones with the wires coming off just because they're a lot easier to work with. I've got this TP4056 LiPo charger, and what that does is that will charge the battery, which is great. I've got it running through a toggle switch, and for the ESP32 we need 5 volts, and that LiPo is 3.7 volts. So that little DD0512MA step up actually brings it up to 5 volts, and that powers our ESP32, which will also power the Arduino Pro Micro, which we've got in our controller. So you could easily do something like this, and the only issue is that for charging, you have to charge through that TP4056, so you'll have to find a way to break that out somewhere, cut a little hole in the casing or something like that. I'll probably do one in the future which actually has the battery, and we'll do the whole tutorial. But for now, this one's not getting it, so I thought I'd give this to you guys so you can do it if you like. But enough of that, let's get on to doing the software part of it. So I've got Arduino IDE open right there. And that's my RR controller firmware, and that's the RR configurator app, which would talk to the firmware. So I'm just going to plug in my USB. I'm going to do the Pro Micro first. And all you got to do is go to Tools. Make sure you've got the right board. So it's the Arduino Micro. It's Genuino Micro in the older version. Then make sure you go Tools and set the port. Then Upload. And it should all go well. Basically, if there's any problems here, you've either accidentally typed something into the code window there, or you've knocked a wire loose or done something wrong there. But it should upload just beautifully. So when that's done uploading, we're going to open up the configurator. Let me grab that. There's a little debugger window there, which you can ignore most of the stuff in there, but it's helpful for me. I'm going to refresh and connect. And you'll see there, we've got the Atmega32U4, so it's detected us perfectly. That's the firmware version 5. And you can see if I push a button there, it's actually detecting that button push as well. And you can go ahead and test all your buttons if you like, it's not a bad idea. Now I'm going to change the name of this one from New Device, because that's a confusing name. That should do it. And the other thing you've got to do is make sure, this is actually the most important thing, is change this address to something other than 0, but less than 256. So 1 is a good way to go. And make sure you press commit to EEPROM, otherwise it'll forget everything you've told it to do as soon as you power cycle it. So now that that's done, I can disconnect that. Now the reason for the address is that's for communication. You'll have one device as master at address 0, and every other connected device needs to have a different address. So the ESP32, that can be number 0, because that's the one that's actually going to be talking to our operating system. So for the board, ESP32, now I'm using the dev board up here. Now with tools, you've got to go to port, don't forget the port, and press upload. Now this one will take a bit longer to compile than the Arduino Pro Micro. This one has a lot of extra ESP32 stuff, and libraries in the code, and there's some Bluetooth gear in there. So it just takes a little bit longer, so be patient for this one. So when it finally finishes compiling and starts uploading, you've got to hold the button down. Now Muggins here is pushing the wrong button, but he'll realize in a sec. Whoops, yep, there we go. So hold down that button, and you'll see it'll stop trying to connect, and finally actually connect. And that'll write your firmware right there. So just give that a sec to upload all the code. And when that's done, you can just go refresh, find the COM port, and press connect. Now sometimes this won't connect on the first go. You see it's trying. Ah, that was pretty good that time. And you'll see this one says it's an ESP32. And if you check devices, you can actually see there's the Pro Micro there in the list. And you can click that. And this is just like we had it plugged in directly. You can see we're still getting that button signal coming through. So you don't need to plug the USB into that one directly anymore, unless we're uploading the firmware. You see there's the 32. So the 32U4 and the ESP32. Let's give this a better name. Make sure you don't change the address on this one. This one has to be address 0. Commit that before I forget to. And you can see, well, they're all set to digital at the moment. So I need to set one of these guys to analog. So if I set that to analog, now we're getting an analog signal from that throttle. So that's working. And now one of these pins, well, two of these pins are onto my thumbstick. So let's find those ones. I could check the wires, but it's sort of quicker just to do the little whack-a-mole here and just try each one. Yep, there we go. Definitely getting a strong signal from that one. You see that one going nuts? That's a floating pin. You see I've picked the wrong one there actually. Let's try again. That's the one. So turn that one back to digital. Alright, you can see we're getting a strong signal from those two analog wires. And let's just call them X and Y. So we're actually assigning them now. This is what the operating system will see them as. And this one, let's call that slider number 1. And make sure you commit that to EEPROM. And I might just set this button to be a button as well. So let's make that button 1. You could go ahead and assign them all now, but it's usually good to test 1 or 2 first just to make sure it's working before you sit there for 5 minutes and assign them all how you like. I'm going to disconnect that now. Oops. I don't know what I'm doing there, just pushing buttons. Alright, so now let's test it. And what we're going to do is connect it through Bluetooth first. So you just go Bluetooth, add device. Now sometimes this finds it in like half a second and sometimes it takes a little while. What I actually haven't done here is just done a little power cycle since I've done the initial setup, which I should have done. So I'm going to try to push the reset button. That actually doesn't do anything. You can see it's sort of coming up there. The good thing is once it's connected, it'll stay connected pretty well. It's just that initial pairing. So I'm going to actually unplug it. This is what I should have done in the first place. Plug it back into a proper power cycle. Add the Bluetooth device and you see it comes up really quick. So connect that. Connecting. Oh, she failed. Let's try again. There we go. We are good to go. So it shows up in there. Ignore the battery because that's actually not connected to anything. It's just always going to say 99%. But now if you open up your little game controller USB tester thing here, now the name there is a bit funky. It's a whole thing changing that name. So that's going to be stuck at that for now. And you can see if we go properties, we can actually test. Now make sure you've got this highlighted when you're testing. If you're not selected this window, it won't show any updates. So there's my throttle working, my X and Y working. And if it's showing up in here, it'll show up in game. So that's button 1 as well. So there we go. That's actually, and that signal is coming through on Bluetooth. That's not coming through the USB. The ESP32 actually does not do HID, and you can't plug it in directly and get a signal through USB like that. So now you can spend a bit of time going through and setting up all your controls, or I think I'll actually put mine together first and then do that later when I can hold it and feel it and get a feel for what I want each button to be. So let's go ahead and put him back together. So just make sure you've got all the wires comfortably tucked away, you're not squishing any of them, and it should seat quite nicely. Get it in there. It shouldn't wiggle around too much. Make sure the throttle can still move. Now these are 8mm screws, 8mm M3s. So just drop them in there, and first we'll just screw this base together. And I'm going to be lazy and only put in, I think, 3 of them, or 4 I should say. Probably better to put in all of them. But I think at this point, making the videos, I've put it together, pulled it apart a bit too many times, and I've had enough of it. So those screws go in like that. Now you're tapping them into the plastic, so when you first do them, you've got to sort of push and turn to make sure they bite in all right. If you don't push for the first few turns, you'll find they don't actually bite in, and you just keep turning them forever. Don't over tighten them either, but they should be gripped quite nicely by the plastic. Now this one's a bit tricky, these two inner ones for the legs. The outer one's easy, but this inner one, I've not showed it very well on the camera there. You've got to get it like up and inside to get at it in there. So it's really hard to drop it in from the top. You have to like reach underneath and put that screw in and then screw it in from the top. And the outer, let me get that a bit firmer. And the outer one's easy, you can just drop it straight in. Unless it does that, and get stuck in the hole. There we go, that's one. Oh, I've done it again. It's actually a bit hard to sort of hold it upside down because we're dropping the screw in. But you can see, you got to push through and get it in like that. Now mine's really easy to screw in because I've done it a few times at this point. But like I said, first time you've got to sort of push and turn so you can bite into the plastic the first time. Once you've got it in like a millimeter, it'll pull itself in. And that's it. Now, obviously this one's still going to be run off the USB, but if you go that next step and wire up the rechargeable battery, then you've got a beautiful little rechargeable battery walk around Bluetooth game controller. So I hope you guys enjoy it. I'm going to do a version 2 of this. I'm going to play with it. I sort of want to make it a bit better for playing like flight sims and stuff like that. That was the idea with the throttle on the left, because I never really liked playing flight sims with 2 thumbsticks. Because the throttle, you know, it always snaps back and you've got to share a throttle with your roll. So I want to have a separate one here, and I'm still not completely happy with it. So if you've got any suggestions for how to update this and put it in the version 2, let me know. And if you guys make one, definitely let me know about it. I'd love to see it. Thanks for watching, guys. Have a good one.